The experiment name is spectrometer dispersive power of a prism. The aim of the experiment is to determine the angle of the given prism, and finally we can calculate the refractive index of the material of the prism. Second, to determine the dispersive power of the material of the same given prism using the readings taken from the different colors. So the apparatus required is spectrometer, mercury lamp, glass prism, readings lens and spirit level. So this is the spectrometer, and we have three major parts of the spectrometer, and this one is collimator. So at the end of the collimator we have the adjustable knob to close or open the incoming light rays. And this one is the prism table where we have to place the prism, and this one is the telescope or eyepiece. At the end of the eyepiece we can view the images. Now the collimator is pointed towards the path of the light source from the mercury vapor lamp, and again it passes through the prism, and through the telescope we can view the images. To find the angle of the prism, as showing in the picture, the light from the source will be splitted into two images noted as B and C points of the prism. The position of the telescope is T1 and T2 correspondingly. So this is the tabular column to find the angle of the given prism for the left hand side and right hand side, because we have two images on the left side and right side of the edges of the prism. So the light rays from the collimator will fall on the single edge of the prism, and the rough surface should be pointed toward us, so that the two edges, that is B point and C point, will getting two different images, so that we can observe the image by moving the telescope to the left side edge of the prism and towards the right side edge of the prism. So we can get two images splitted from the path of the collimator. For example, from the right side of the edges of the prism, now it is adjusted, so that value of the vernier A is noted with respect to the zero division of the vernier scale, and simultaneously this is the vernier B readings, and this will be noted as in the tabular column right hand side. So 243 degree 10 minutes, and this is the total reading 243 degree 10 minutes, and vernier B, the value is noted as the 63 degree and 6 minutes. The final value is noted. Simultaneously we can move the eyepiece towards the edge of the prism on the left hand side. So the vernier A reading is noted as around 123 degree, and the vernier B reading roughly noted as 303 of the main scale reading, and the vernier scale coincidence is noted as third division. Actually in the vernier scale there are 30 divisions, 0 to 30. You can see the top side of the vernier scale. So there are 30 divisions. The third division is meeting with the or getting coincidence with the main scale division, that should be noted as 3. And for here 10th division of the vernier scale is getting coincidence with the main scale. So this is the value 123 degree 10 minutes, and for vernier B 303 degree and 3 minutes. So the values of vernier A and B is assigned as R1 and R2 for both sides. The average is found to be 120 plus 120 degree 3 minutes, and the average taken for determining the angle of the prism, and it is found to be 60 degree. So actually the prism holds the angle always to be 60 degree theoretically, and now the same value is found practically as the same. Now we are going to find the angle of minimum deviation of the prism for different colors. Actually minimum we have to take for 2 colors, that is enough. But we are taking for 4 colors or 5 colors here in the list of the tabular column, starting from violet, blue, green, yellow and red. So now we are going to see how these readings are taken from the spectrometer. So now the prism is rearranged from its position. So then now you can see the rough surface of the prism is pointed to your left hand side with respect to the collimator, so that you can view the colors at the left side of the edges of the prism. By adjusting the prism table, you can view the different colors, and you have to determine the minimum deviation for any one color through the edge of the telescope. Now we have placed the telescope along the violet color. So this is the position. For this violet color, we have to observe the Vernier reading of A and Vernier reading of B, that is Vernier A and B, and that reading is noted as 135 degree 10 minutes. And for Vernier B, the reading for violet color is 315 degree 30 minutes, and final reading is obtained as 315 degree 46 minutes. Here 30 should be added with the 16, so that 46 minutes. Next, for the blue color, we have to further move towards left, so that you can view the next color blue and successfully up to red color. Correspondingly, for every colors we have to take the readings for Vernier A and Vernier B, and those values are entered here. So up to this column we have observed and taken the reading. So this one is, we have to calculate the angle of minimum deviation for every colors. So this one is noted as R1, and this list is noted as R2. So here this one is R2. So here instead of 360, so it can otherwise noted as 0, because 0 equals to 60 for a circle. So this 360 or 0 can be assumed based on the readings obtained in the total readings of the Vernier B. So for example, here for the directory is already, this is the initial adjustment of the directory. For one side, that is Vernier A, it is 180 degree. 180 degree minus 135, the value is noted here, and for every readings in the Vernier A total reading should be find the difference between the 180 degree. Simultaneously, for Vernier B total reading should be find the difference for 360 degree, and those values are noted, and these are the mean values for Vernier A and B, and the refractive index mu is found using this formula sin A plus D by 2 and sin A by 2. Already we have found the value of angle of prism as 60 degree in the previous tabular column. So in this tabular column, the A value is fixed, that is 60 degree, and the D value for every colors are different for different colors, that should be substituted here, so that the refractive index of the material of the prism is found to be 1.5 approximately. Now we are taking any two colors, here violet and blue. Using that we can find the dispersive power of the prism. So we already found the refractive index for the violet is 1.578 and the blue is 1.568. So those values are substituted, and the value of mu, that is the average of these two values, is noted as mu, because mu equal to mu1 plus mu2 by 2, and based on the formula -1. So if you calculate these values, you can obtain 0.0174, which is the dispersive power of the prism. So here is the dispersive power of the prism, and I'll show you the. So this is the dispersive power formula, mu1 minus mu2 whole divided by mu minus 1. So instead of mu1, mu2, we have taken the readings of violet and blue. Instead of violet and blue, we can take based on our own choice, any two different colors can be substituted there, and mu should be the average values of those two colors. So this is the result of the dispersive power of the prism, angle of the prism, and dispersive power of the prism 0.079. No unit.